Hello again. Long time no see. Chat, let me know, is the audio better? It should be. People were suggesting, hey, check the microphone batteries, check your sound card, reboot your computer. If you didn't notice, I actually did reboot the entire system while the chat was down. But yeah, it seems to work. The stream today is also on a low latency mode, so that the feedback loop between you guys and me is a bit quicker. But yeah, it was weird. I rebooted the entire system. It didn't change anything, and then I just closed the OBS Studio and opened it up again, and all of a sudden it's working. Yeah. The ways of the Windows are mysterious sometimes. Okay, that was the most stress I've had for a while. Okay, but this camera is a bit overexposed, so let me fix that while I try to explain what we're going to do today. So, the idea more or less is getting the printer, not exactly printing, I don't want to promise too much, but to get it moving at least. That's the idea here, to at least get like X, Y, Z moving on their own. So let's do that. So first of all, we're gonna have to wire this thing up completely. But told me to reboot. But yeah, wiring, stepper drivers will need to go in. What else? That's pretty much it. And firmware. Yeah, firmware configuration. That is the other big thing that I hope I will be able to do today. Okay, so now one big thing I'm noticing is that this camera is out of focus, which is okay. But over the you can do it. Over the last 2 days where this printer was on its own, the RAM port here slightly popped out. And especially on the side over here, the pins were, sticking out a bit too much. So I think what I'm going to do is clip these 2 pins down here. These were pushing on the power input. Just clip them down a bit, and then it shouldn't slide out as easily anymore. What was the issue? I have no idea. Thanks for the tip, Mike. I have absolutely no idea. Yeah, only 10 seconds delay. That is the low latency mode. On the downside, if you have a weak internet connection, you might see a bit more buffering. But unfortunately, there's nothing you can change about it on the viewer side. But I'd rather have a bit less latency, and make interaction and reading chat and responding to that a bit quicker. Okay, thank you for the tip, Duan. $10, saying keep up the good work. Yeah, some people say what I do here isn't work. I disagree. It's not the worst type of work you could do, but it still is. Okay, so yes, and we do have an overhead camera. So we need to wire up motors. We need to wire up end stops. End stops already have their cables right there, and the bed, which is this stuff. Yeah. Okay. So let's get the heated bed spiral wrapped up. Because I mean, right here, the x-axis, I checked that this thing is actually in a pretty good spot, so we can just zip tie this over here and zip tie that right up here with another zip tie all around, and keep it close to the board right there, but still allow the x-axis to move without that dragging. Even if the carriage moves down, it's still going to be okay. But that's out of the way for now. Let's wrap up this bed. Now this spiral wrap might be a bit too small for this exact wrapping job. But the good thing is this stuff stretches, and it will adapt to the size of your wire bundle. We've got a thermistor in there. The stream is stuttering consistently. Not bad, just a little. Yeah. Stuttering here too. I can try to give OBS Studio a bit more priority. But I'm hoping that's not going to crash audio again. Let's see. So now, I mean, this is on a USB monitor, so I'm not sure if this actually of what I'm seeing is accurate to what you guys are seeing. But yeah. What power supply did I go with? I went with a Meanwell one that I had sitting around. But of course, the idea is that you're going to be able to drop in any sort of any sort of cheapo Meanwell clone Chinesium's power supply, and you know the only thing you're going to have to change is a bracket on the bottom here. Tips coming in, guys. You are hammering me today. This thing is not on auto refresh. Start. Better audio Chewbacca. Was it honestly sounding like Chewbacca? Thanks for the $5 tip, Daniel. And WF Pellet here, $20. Thanks for getting this together, Tom. What a ride. Also 10 euros through stream tip from Valentin. Guys, I'm not gonna finish reading. Come on, stop sending tips. But yeah, people were asking on the Patreon Hangout today whether stream tip or the YouTube Super Chat was the better way to send tips, and I think the Super Chat is. It has less fees and it's more neatly integrated. So I'm thinking I am gonna stop having stream tip on there just because it's like another service I have to take care of. And it goes through PayPal, so with every tip they take their cut, and then stream tip is Super Chat is a bit nicer. Also $20 from Adam. Much enjoy these streams, Thomas. Thoughts on doing another DIY trial printer for another stream down the road? Yes, definitely. That is something that I definitely have planned, because this is turning out to be a lot of fun. And you know, obviously this is sort of a first try experiment sort of setup with, what did I just drop? With a machine that I kind of know, and a machine that I have used and sort of know the ins and outs of, and one that is just cheap and accessible. So if it doesn't work out, I could just scrap the entire thing, and it would, God. it wouldn't matter that much. So yeah, down the road, definitely I do want to do like a super premium printer down the road, which is, I mean, for $1,000 or so, for 1,000 euros roughly, you get a huge amount of 3D printer if you build it yourself. Obviously you get no support and no development done for you. You have to do that all yourself, unless you're doing all open source. But yeah, that would be a nice project as well. Also, thanks for the tips from Chris, $10, saying thanks for coming back, made his day. And Paul is just saying stop sending tips. Well, not gonna stop you. Much appreciated. Thank you, guys. All right, scroll back down. This is actually stressful. What kind of cable management is that? Not the best, to be honest. This is not the best sort of cable management. This is going to be dragging on the bed. Sort of, yeah. But this spiral wrap, nope, that way. This spiral wrap isn't like the neatest option to manage cables. You do have to like add filament. This is Tallman 910. You do have to add a relatively stiff piece of plastic or filament inside there to keep everything in place and keep stuff from kinking. But you know, this spiral wrap just helps really well with keeping stuff together, and you know, not having the entire thing split up into individual strands. So it's pretty good. It's pretty good and decent enough. So that's the thing. Loeft is asking Fusion 360 Onshape or 123D design. I'm not new to CAD, Onshape or Fusion. Both are good options. 123D design is very stripped down and very dumbed down. Okay. 3D printed drag chains. I did mention that in another stream of this series. When you do print a drag chain or just grab one of the... Do I have one of those? Yeah. One of these Chinese drag chains that just have the super slim bend radius. Chances are, just by bending the wires repeatedly inside that small radius, you are going to wear them out quicker than if you actually just enforced a radius with, you know, putting filament or something in there. Also, good evening, Ben from Hawk 3D Proto. Nice to see you around again. Ah, yes, the Sweden meetup. And Zeppi is asking, SolidWorks or Inventor? I've used both, but did end up sticking with SolidWorks through my college years just because... Wait, I don't have long ones? Just because SolidWorks is what everyone used and what my college used. But, you know, when it comes to CAD tools, my attitude has been for the recent years, they're pretty much all the same. It doesn't matter much which one you use, whether it's CATIA or SolidWorks or Inventor or AutoCAD or any of those. They pretty much all do the same things. They just look a bit different and feel a bit different and, you know, integrate features differently. But the core CAD functionality is, you know, pretty much identical between all the different tools. Okay, maybe CATIA, well, it does CAD too, but it's pretty atrocious to use. But yeah. Okay, I should maybe have waited putting these zip ties on because we are going to add the wires from, let's see, from the power supply over here. We still need to route those on the bottom here somewhere. And I will need some extra wire for the power supply. Let's see, I need to get some of that. Yeah, so this is coming out nicely. So as you can see, as we move the bed right there, so this is the end of those. As we move the bed, it's kept in mostly a radius. It's rubbing slightly here, which I don't like that much. But it's at the very extreme, it's at the very front of the printer. And if anything, we can always slightly reroute this so that it's actually sticking out like that. Okay, let's clip these off. I will need to get some thicker wire for the power supply to the ramps. Thank you for the tip, Robert. Saying, thanks for the series, very well done. It's the best method to learn how 3D printers work. I would agree, yeah. Building a 3D printer yourself is the best way of getting to learn how they work. And I definitely recommend that. But for now, I'm gonna grab some wire. Did I actually, oh, I removed the, I thought I had an overlay there. Where's the mute? That should have had some David Cutter music in there. If it's not playing, there is something wrong, but that's the least of my concerns today. So, what is this? Yeah, that looks, I don't know. So we've got 1.5 and 2.5 millimeter squared right there. Let's check that out. So right there, these two options I've got at hand. I think either one is fine. I'm just gonna go with the thicker one. 2.5 millimeters squared. It just feels better. Plus, with these heated beds, with these 12-volt heated beds, you can use every tiny bit of voltage you can get, and the less voltage drop you have in the wires, the more heating power and stuff you get. So definitely don't want to go wasting anything there. Well, maybe for the hot inside we can use the thinner one and save a bit of cash, because this is like, I don't know, €1 and there's like 70 cents. But I don't recall which one of the inputs on the RAMs actually goes to the heated bed and which one goes to the hot end and the other stuff, so I'm just not gonna bother. So 2.5 millimeters squared for everything. And that's gonna get routed down here a lot. Well, we could route it on the back. We could route it around the back, which is a bit more accessible, but then it's gonna stick out over here. Or we could route it through the bottom, like that. But there's not anything to zip tie to, so it's gonna be on the outside. Executive decision. So one there. And we're going to make a video of the complete build. That depends on what you're asking, Multidomar. There are already 5 videos on the complete build online. They're about 8 hours in total. So the videos are there. Just have to watch them. Also, tips, 5 years from Austrian boss fan, where is it? And 20 Danish krones. Hey, you guys want to start a fight again about which types of krones is better? Danish, Finnish, Finnies? No. Euros, krones? Swedish krones? That was fun. Thanks for the tip, Radio Nuclear 95. Okay, we can tilt this guy up. So these clamps right here, I'm gonna actually put some crimp connectors on the wire, because people seem to not like me just use bare wire in these screw clamps, even though bare wire I think isn't that bad to use in those sort of clamps. But crimp connectors it is. Yeah, just worked with a bunch of concrete and stuff over there. Very dusty in the workshop right now. Right, so American wire gauge. Do these fit? These do fit. Apparently. Yes, these do fit. The only question is that the right size? I think it is. How's the hang printer coming along? Yeah, that's exactly the room that the hang printer is intended for. Eventually. One project after another. So one side is going to go into a screw connector like that. well, the green one over here, if you can see through the reflections, but you probably know that one. One side's going to go into that screw connector. The other side is going into these shoes and clamp into the power supply. Those crimp connectors? No, not the tiny ones. Oh, look at that. Look at that thick, juicy copper core right there. Yeah. Look at that. Look at that. Nicely braided, sort of. That's some nice stuff, actually. Thanks for the €1.09 tip from Joachim. Cool. So these are like the big brothers of the tiny crimp connectors we used last time. They pretty much, I mean, I like them a lot because they can take a ton of current. They're easy to apply. They're cheap. They're nice. They're nice. Ah, yes, reverse polarity and that sort of stuff. That's going to be interesting, but like last time, I'm going to use because these wires have a marking on them. One side has these grooves, and I'm going to use that for a negative, just to stay consistent. I don't know if anyone in chat knows like the official sides, the official polarities you're supposed to use these wires with. Let me know, but that's how I've always been using them, and that's how I keep my projects consistent. There you go. There's one, and the other side is just going to be, well, I guess I could, let me see, do I have those? Regular ferrules. Let's see. That's too small. That is too small. Nope. I don't think I have the correct size for it to be 2.5 millimeters. Swear it. Nope, only have the smaller ones. Unfortunately. Well, is blue always the same? 2.5. Oh, well, it says on the pack 2.5. Okay. Well, then let's do that for the other side. Plus to the mark cables. Okay. Yeah. Now, how do I crimp these? That's the better question. Can I actually crimp this with this guy? Probably. Maybe. 1.0. Shit. Let's just try it. So I don't have let's see, I don't have the correct crimping tool for these regular ferrules. I know it's just a really simple crimping tool. I am going to try with the DuPont crimper. Let's just see if that works out in the largest slot. It's going to crimp something. I'd call that good. I'd call that good. Yeah. See if I can pull it off. No, that is a solid connection. Okay. Maybe not quite to spec, but I guess better than no ferrule on the end. Right. 1, 2. So which side is the thinner one? I guess this side with the thinner side towards the open end. Ugh. There we go. And that is one set correctly crimped. And somebody in chat said that the positive side is supposed to be the one that's marked. So let's do it this way. So these with the... Yeah. This camera should have autofocus. It should focus by itself if it detects that it's blurry. But apparently That's something we still need to wait a few years on. So this side with the grooves on there is going to be the positive side, and the plain one is going to be negative. Okay. Tin the wires? Nope, not in the crimping connector. What is 14? Mark Firmware. Yeah. The imprinted or marked side is usually the neutral negative. Okay, well, we've got opposing opinions. Let's see. Let's just figure that out through chat. Simone, are you there? Can you maybe see if Nightbot will be able to do a straw poll real quick? Or one of the other mods? I mean, if you do it through the commands, I think Nightbot will actually read the answers that are posted in chat. There you go. Might take him a while to respond, actually. Again, for everyone asking about printers that I've not tested or reviewed yet, I cannot comment on something like the ANET A8 or anything like it because I don't have one. GearBest promised me one 4 months ago, but I've still not gotten one. By the time they got back to me, it was out of stock. So I don't really have an opinion on the ANET A8 because I've not tested it. That doesn't look good. Actually, these things are dirt cheap. Let's strip this a bit more. So the commands for Nightbot are all listed on the commands page. They are only available to mods, so everyone else don't even bother. And I think they are fairly well explained. Yeah, you can do a straw poll manually, but if you do it through Nightbot, Nightbot does integrate it and post it and does it very nicely integrated into the YouTube chat. All right. Perfect. Obviously, you can use these without the connectors on the end. You can just bodge it and use them plain. You can just jam the loose wires in the power supply right there. But having the crimp connectors on there is just nicer. Let's see if Nightbot does that. Is it possible to run 2 heating cartridges in parallel in a hot end? Yes, it is, but you will need to take care that your board doesn't melt down. If you've got a good board, then usually they will work. But if you've got like a cheaper board, then it might cause some issues in the long run or blow some fuses. That's like poll new and then the first whatever that dash is. And then the title and then the first answer and the second and so on. Okay. While you guys figure that out, I'm gonna grab a power cord. Actually, I do have those here. Why would I even grab something else? Short, long, or a medium one? I think like one of these medium length ones. I'm gonna be able to use some extension cords. Again, you could use You could use a socket with this. You could use a socket with the with some sort of a power supply shroud down here, and I'm just going to crimp in or wire in a cable directly. Just gotta be careful not to touch this thing down here. Plus these IEC cables are, it seems like they're multiplying around here, so using one of those isn't really a big deal. Will I ground the wooden frame? Actually, if you look at it, it is grounded through the power supply. The power supply is screwed to the wooden frame, so we should be safe on that side. So no worries there. Those terminals are exposed. There is a cap that comes with the power supply that I probably just lost. There is a cap that goes over the terminal. It's not great. Not great, I know. There should definitely be some sort of cap over it. Let's check the straw poll results. Okay. It looks like well, we've got a very clear answer, and the answer is that it doesn't matter. I'm just going to stick with what I feel is right, and that is marking the positive one. Negative? Wait, what did I say? I have no idea. Marking the negative one. Whatever. Poll results. That only works if it was created through... No, it does... What? What is that poll? We are having spinner type. Nope, that poll was created a while ago. That was the last one that Nightbot created for me. Last thing I want to do here is to damage any of the inner insulation. So just look away for a second. And I know this is the wrong wire for this, or the wrong wire, the wrong knife for this. I should have used a proper knife. You expect excellent quality? You might get excellent print quality. You're not going to get excellent quality on the printer itself, that's for sure. By the way, what is the best way to strip like the outer insulation on wire like that? Does anyone have some tips there? Right, so we've got this guy. Let's wire it up. This is 0.75, I think. Should say on the cable on the outside. Obviously, this guy is too small for directly stripping. This one, yeah, 0.75. That is okay for the main side because we are running on 240 volts. We are not using a lot of, or drawing a lot of current through these, so perfectly fine. That's going to be these. Those fit as well. Rotary coaxial cable stripper, but this isn't a coaxial cable. This is the wrong type. This guy is too long. What is my opinion on the Sculpto 3D printer? I don't have one. I've not tested it. I can't comment on it. Very simple opinion there. that's phase or live. And neutral. Let's just double crimp these to make sure that they are very nice and tight. Don't want these coming loose. There we go. Okay. What I am gonna do though is zip tie this guy to the frame so that we're not tearing it out if someone yanks on the cable. Let's see, we've got protective earth right there, we've got neutral, and we've got live. These are the European wire cables, obviously. There we go. And this, I just double checked, I just had a mini heart attack. This is in fact a 12-volt supply. Yeah, I know Yokari makes great stripping tools, wire stripping tools. I didn't know that they made one for like double insulated ones too. Ideally, you would torque these down, like if you want to be really anal about just sticking to specs, but this isn't the machine about sticking to specs. And is this going to clear it? No, it's not. Okay. I guess we have to go like this. And zip tie down here. Yeah, you could wire a plug in here. It's not that hard. Same way, if you have solder connections, and that would be the way to go about it. Let's see. Does this actually sit on the wire? Yes, it does. Neat, good. So I'm guessing it's just going to be over here somewhere, like that. How do you make sure you don't swap live and neutral when you plug it in? You don't. It doesn't matter. It's our European plugs are completely reversible. Every single one is. This is like the East European ground connector, and ours have them on the side here. And you know, we can plug them in like that or the other way around. Totally okay, because you know, most of our, well, all of our circuitry is grounded. It has the protective earth. You can get these smaller ones, the 2-prong ones, but there are very tight rules in place about which devices can use the 2-prong ones without the protective earth, and which ones can or have to use all 3 poles. So again, every single outlet has protective earth. Okay, that's that. Let's see. So power supply and of course these guys. Straw poll results, nobody cares. So I'm just going to wire this up as marked 1 positive. That's the way I went about it, right? I don't know. I don't even know anymore. And these are going to come out the other side like this. Come on. There, and then they're going to go down here and up there, and that is perfect lengthwise. So this power supply only has 2 terminals per positive, negative phase output. Yep. Wow, it is focused, but it's at the wrong focus plane. There we go. This one only has 2 outputs. It's a 20 amp supply, so each of these outputs is going to deliver 10 amps, which is okay because these terminals can take quite a lot of current before they melt down. According to a Swedish cable manufacturer, you have to hook up your wires in the same direction as they were drawn to minimize disturbance. Okay, that's the first time I've heard about that. So marked over here. Also, thank you, Carl, for the 100 Swedish krones tip. Earth wire should have been longer than... yeah. I know, so it's the last one to rip. And also I should have connected it first. Did I? Did I do? I don't know. Drunk build. Only if you guys get drunk too. Okay, 1, 2, I think, yeah, that's probably not much better. And this one's going out. I should maybe have added the one last. The neutral to ground on the power supply as well. I think that might actually be internally done. I don't think it's a good idea to do that externally as well. I don't know how these are wired up, to be honest. I could check. That clears everything. Oktoberfest drinking build. Like, if we're gonna start the drinking game here, every time someone asks about Core XY or about the NAD8, that would be over within minutes. I don't think that's too great of an idea. Okay, so I can get my fingers on the live pins there. Yeah. Whatever, it's gonna be fine. This is not the way I'd recommend it, obviously, because if you reach in here from the top and just get your little fingers on the, well, maybe not on ground is okay, but live and neutral, then it's gonna be a very refreshing experience, to say the least. Don't do that. So marked ones are positive. Yes. Yes. Okay. Would I upgrade my printabout play to what? What is there to upgrade? I actually like the printabout play as like a simple machine. It is an extremely simple machine. I like that simplicity, to be honest. Just not having to worry about a heated bed, or not having to. It gives you that peace of mind that yes, I'm only going to be printing PLA with it. That is fine. I'm not going to be printing huge models with it. That is also fine. It's very enjoyable just taking a step back and having a machine that is not that powerful and not that complex. So motor wires. Again, I don't have any matching ones or any proper motor wires for these. I did borrow these from another machine. If you buy stepper motors, they will usually include motor wires too. If you know, on the one side they might be just fixed to the motor, or if they are pluggable like these, the seller should include a wire for each one. And if not, they're not expensive. It just takes a while to get to you. Let's use the slots that I cut down here to route stuff. Thanks for the tip, Ben, from Hog3D Proto. I don't know, how does StreamTip show that to you? Does that show you? No, StreamTip does. Does StreamTip do only euros or pounds? Okay, StreamTip converts it to euros. That is weird. So that's gonna route like that. Nope. Yeah. So back here. There's not a good angle to get at it because right now it is turning into a bit of a mess. I guess that's good enough. There. So that's the second Z-axis motor. And this ramps does have, yeah, 2 outputs for the Z-axis in parallel. That is okay. There's one, actually, this one can route towards the back. Anything crashes into? No. And then while we're at it, I guess we should route this guy towards the back as well. Okay, now this will be a good time to mark the motor cables and the wires coming up, because like yesterday I tried figuring out which fan wire was which one, and it was a bit tricky. Marker, I am gonna get some sort of marker. I do have a silver grease pen, which is great for that sort of stuff because it writes on the black connectors. Everything is dusty. Why did I drop? I really hate having to work with concrete because it's like, no matter what you do, as soon as you're working inside, everything gets dusty. Any sense to get a rads instead of a ramps? I don't recall what the rads is. There are so many board variants, so many board types these days. What was that? Was that the 32 bits? Arduino Due compatible one? Right. Pro tip, if you don't have like a label maker or something, get some white electrical tape, stick that onto your connectors or wherever else, and suddenly you have a writable marker surface. That is Z2. You can also use it as like little loops around the wires themselves and just loop it around and use it as tags. But if you can get it on the connectors, then you are going to have a very clean and very slick solution right there. And this is the y-axis. What else? So extruder is already up here. Let's also label that one. And just labeling and making sure everything is at least somewhat clear, I think is one of the bigger jobs, or one of the things that help the most when maintaining your 3D printer and making sure it is something you will be able to use a few years down the road if you want to upgrade something or just change things around. Also end stops. This is the X end stop. And these are just the little wires that came with the end stop PCBs. The MakerBot end stop PCBs. Okay. Rambo is just rams smashed into one board. Not exactly. Not exactly. It has a few different design decisions, like, you know, not using polyfuses. That's the one big one. Yeah, total cost for this build is to be determined. I've not, added everything up yet. But for anyone expecting it to be cheaper than like an ANET A8 or something, it's probably not going to be. It's probably not going to be. The thing is, the idea is, out of the box, yes, it's going to be very simply built. It's going to be a very simple, cheapo machine, wooden frame, obviously, and stuff. But I am hoping that, first of all, once those Mark 42 beds become more widely available, and yes, there is an Indiegogo campaign for a Mark 42 compatible bed right now. Once those become available, that you're just gonna be able to plop that on here, use a new firmware, and get most of the features of the original Mark II. And obviously, when building it yourself from scratch, you can make decisions like which sort of a hot end do you want to use? Do you want to use an E3D clone? Do you want to use an original E3D? Do you want to use a Light 6? Something else that fits in here. Whether you want to use a 0.9 degree motor or a 0.8 or a 1.8 one for the extruder. What sort of Z-axis you want. It's all those things that you can decide while building, whereas when you just buy a kit machine, you don't really get those options. Obviously, zip tying these to a flat frame isn't that great, but it's good enough. That actually looks pretty decent. Just move around slightly. Okay. Let's get these out of the way real quick. Okay. So that is the x-axis. What else? We need the end stop for y. Yeah, that one doesn't have anything in it yet. There you go. So that's there. End stop, wire. So with the wiring set, I don't feel like we actually needed that many of those 14. What am I trying to do? See a white connector, try to plug it into the motor. I don't think we're actually going to need that many of the wire set connectors, because most of these parts have wires on it. But again, that is something that will be topic of like a build notes video later down the road. Prusa is a Mendel clone. Prusa is a Mendel based machine. Yes, it is a cells Mendel based machine that is simplified. If you know the history of the Prusa machines, the first Prusa was super simplified, even using PLA bushings instead of actual bearings, because back when the cells Mendel was a thing, LM80Us weren't a thing. They were literally using ball bearings, like radial ball bearings, 3 on a smooth rod, and just 1, 2, 3, and just guiding the rods like that, which was just a horrible solution. But then again, LM80Us weren't that widely available back then. You could get a few, but they were pretty darn expensive. It's not like today where you can go to AliExpress and just get a 10-pack for $5. You'd pay $50 for a full set, plus the rods, which weren't, again, as widely available. Click, click, click. That's that. So that is the filament guide from the y-axis, from the bed. That one is coming off as well. Okay, that's the bed. So that's on an output. I will need to look up which output is which, because the, well, this ramps at least has like 3 equal outputs. These are 3 MOSFETs that are used in the outputs. Let's see there. I think they're all the exact same type. These are P55 NF06L. And this one as well. These are pretty crappy MOSFETs. I've looked them up. They have about twice the resistance as even a cheapo type like the IRLC44N. So I'm not going to expect too much from them. But we're just going to have to see if they are actually good enough. Yeah, I feel bad for you for having to build the original Mendel JetGo. That was actually my first printer as well. I started with the original cells Mendel. The Prusa, it wasn't even the i2, the Prusa Mendel. It was just the Prusa Mendel back then. Was out. It was, you know, a very novice design, and when we decided to build it as a college project, we're like, should we build this new thing? But it's using like PLA bushings and it's like sort of fishy and really, really cheap. And you know, these things were still like $500, even for the cheapest Prusa Mendel, if you counted all the parts. That was, you know, maybe a bad decision going with the cells Mendel. But hey, the cells Mendel actually did work pretty well after many hours of tuning and trying to understand SkineForge. But yeah, it was eventually replaced with a better machine. So this right here is thermistor for, where are the thermistor plugs here? There. This guy here is thermistor for the heated bed. So I'm gonna crimp some DuPont connectors on this guy because they plug in up there, which you can't see. They plug in right up here, and that's going to be long enough. These are actually like silicone wires or something, or Teflon wires even. Let's see if I can script them. You love SkineForge? Well, you sick bastard. That's like a that's a pretty horrible fetish to have. I'm glad that slices are as good as they are today. I really am. SkineForge was not something I was happy to use. Cool. Please show how to wire inductive sensor. Yes, there. This is it. This guy plugs into the Z negative end stop like this, yeah, Z negative, there. Totally wired up right there. The thing is, we are using a 5-volt inductive probe, so this guy doesn't need anything. It doesn't need any voltage divider. It doesn't need any resistors, any sort of voltage adjustment circuitry. It just plugs in. So yeah, that is pretty cool, and it's pretty nice to have these available today. I never know how to hold these crimping pliers, because you do have to insert the wire from the left, but you sort of have to. It's almost like they're left-handed pliers. There's one that is a perfect crimp if it doesn't slide out. No, it does not. What are the odds of a first print today? Probably fairly low. I know I'm going to lose about 500 viewers for that. But we still need to configure the firmware. The firmware is still, completely naked. I downloaded it. Yes, I have an Arduino IDE ready to go, but it is completely unconfigured. And considering that we already had some technical issues and it's already like 10:30 p.m. here, I don't think we're actually going to be able to do the first print. Plus slicer configuration. It's not going to be a whole lot to do in this. Oh, well, I have to compress these in the slicer, but setting something up, slicing something, and then waiting for it to finish is probably going to be too late. Somebody actually asked about the 12 versus a lower, higher voltage use of the probe. So even with this probe, I think this is specifically 5 volt. It's at least it's labeled as 5 volt. But what Tech2C was testing was like with different probes at what voltages they were better or worse. And apparently there are differences, which I would expect in precision, but I wouldn't expect any differences in actual trigger distance, etc. to be there. 10:30? Come on, it's not even late yet. It's just the evening. Let's actually loop this guy around so that we don't directly pull on the connectors there, and also give ourselves a bit of room to actually plug them in. So this is the heated bed. Again, that's something I'll have to look up. Maybe in the firmware which of these 3 ports it goes into. By the way, I've been considering like stuff. You might have seen the channel branding upgrade that I've been going on with new graphics and all that sort of jazz for the logo and the animations and the starting soon screen and that sort of stuff. D8 is heated bed. Should I look into getting like t-shirts made or stuff, or stickers, especially on Patreon? That would make sense, just having a sticker tier. Is that something you guys would be interested in? I'm thinking like putting the design is like a low poly thing now. That's sort of what I'm going for. Maybe doing like a low poly hybrid frog design print. I'll have to see what I can come up with there. Like a sticker. Someone's asking, are there rules for chat? Well, just be a nice person, alright? It shouldn't be that hard. Do how your mommy told you. Sweatshirt. Teacups! Ah, yes! It's probably going to be hard finding low poly teacups. But I've heard that there is such a thing. Somewhere. "3D logo or sticker which you can print." I don't want to start a cult. I don't know. Balloons? Ah, balloons, yeah. Balloons could be nice. Come on. Most of the time these strip pretty well, but like for the silicone wire, it always leaves these strands on the edge, which you're gonna have to come back and strip manually. Not a huge deal. Sort of annoying sometimes, but usually works. Bobbleheads? Bobbleheads? Yeah. What is the name of the blue connector? These guys. These are usually just called like terminal blocks, 5.08 or 5mm terminal blocks. They are 5 amp rated. That is like the official rating on these things. 5 amps. Some cells will rate them as 10 amps, which I think is wrong. There are some that are a bit more massive, but yeah, typically there are 5 amps. So using them with a 12 amp heated bed is overloading them by quite a bit. Thank you for the 50 Norwegian krone tip, Torsten Mitte. Yeah, Tom's hot. And something that has been suggested and something that might actually happen, who knows, would be a Tom's 3D printer, like not just a DIY kit, but like an actual sales ready machine. I am talking with some guys right now. Maybe we're gonna make that happen, but it's not gonna be like a printer that I personally sell. It would be a printer that I like co-brand and co-engineer or something. But I can't really put the time in for actually selling a 3D printer and taking care of logistics and servicing and business. I've already got more to do right now with just YouTube than I have time for. Branded filament? Maybe. Okay, a few parts from the accessories baggie from the ramps. So I'm glad they did include these. So you do get a bunch of jumpers. If you've ever built a PC, well, I guess nowadays you don't need them anymore. But if you've ever built a PC like in the last 5 years or so, you will know these are just bridges that bridge 2 pins and essentially short them out. They have a little wire or sheet metal part on the inside. And these go in the ramps and adjust the micro stepping settings for the stepper drivers. And as you might be able to see right here, these stacks of 6 pins underneath the stepper drivers are where these jumpers will go. And the only real configuration you will need to know is all of them in. There is no other configuration that makes sense, I think, even for a for an 8-bit board like this. Just put them all in. E0 is over here. Put them all in, and that will put the, well, at least the regular 84988 Allegro drivers into 16 times microstepping, which is the mode you want to be using. Same configuration for Texas Instruments DRV8825 drivers are puts them into 32-bit microstep or 32 times microstepping, which is a bit too much for an 8-bit board to handle at decent speeds. So I would recommend stepping that down to 16 times. Maybe on the extruder you can leave it on 32 times microstepping, but for X, Y, and Z, ZXs especially, just drop it down to 16. Makes it a lot easier. I just messed up. Makes it a lot easier for the small little Mega processor. The pins connected without the jumpers. Yeah, so I'm not wiring up. Well, I could just throw them in, but you might notice that this is, in theory, a dual extruder board. You could put 5 stepper drivers in there. Somebody has already asked, hey, why did you only spec 4 stepper drivers? Well, because we only need 4. We're only going to have X, Y, and the Z axis. No, 1, 2, 3, and then 1 extruder. That is 4 axes in total. That's enough for a single extruder 3D printer. If you do want to add that second extruder, you will also need some way of controlling temperature for that second extruder, because the back when the ramps was designed, part cooling fans for PLA weren't really a thing, because people weren't printing with, well, they were printing with PLA, but they were also printing a lot with ABS. a lot more with ABS than today. And like the part cooling fan, I think wasn't really discovered back then. I don't think any of my early machines had a part cooling fan. So this thing only has 3 outputs, which is a heated bed, an extruder, and an extruder. But nowadays, obviously, you use one of them for a part cooling fan. Okay. And stop. Let's quickly label this guy while we're at it. Am I gonna give it away? It's probably pretty unshippable. It's gonna split into 2 if it gets shipped around the world. That is the y-axis end stop. So the wires on these are color coded, and I would assume, yeah, sort of positive, negative signal. That is exactly how the ramps is wired up as well. Positive, negative signal, and that just plugs right in. We're going to do that in a second. And this one is the x-axis from over here. That wooden frame, yeah, that wooden frame actually wouldn't be that bad if it didn't cut out these 2 notches. These 2 notches over here, there and there, actually do take a good bit of the rigidity of the frame out, because, you know, when it flexes like this right there, and these are obviously weak points where the lower part will twist. The wooden frame actually functionally is perfectly fine. There's really nothing wrong with it. Okay, D8 is normally heat bed. Yeah, I saw that a second ago. Thank you for that. Should we wire that up? What else? So we've got, let's just double check. We have, that webcam is horrible. Still, we've got everything from the x-axis. We've got 2 fan wires. One of them is going to get wired directly to 12 volt in. That is the hot end cooling fan. And the other one, the part cooling fan, is going to go on an output. We have the heated bed, we have power and a thermistor, that is good. We've got the x-axis, which is an end stop over here, and the motor. And we've got, well, everything from down here, the y-axis. We've got the end stop and the motor wired up, and the power supply with obviously 2 lines of power. So we should actually be good. We've got everything we need. We have everything we need. Yeah, so let's start plugging stuff in. Huh. Tesa Eco Repair apparently is a great bed adhesive. Low temperature, or put some glue stick over it. Glue stick is always like the my go-to solution for getting stuff reliably unstuck or stuck, depending on what I need. Okay. Z2, where's my Z1? Oh, ZX is 1. That's the one we're still missing. Nope. This one. Where do we route this? Probably just underneath. Right there. Yeah, that feels good. That feels good. Right, let's start plugging things in. So the motor wires, let's just touch on that real quick. The motor wires just have these standard 4-pin DuPont connectors on them right now. You can plug them in like that, or you can flip them around and plug them in the opposite direction. And for the most part, there is a correct way to plug them in, and there is a theoretically correct way you can work out which of the motor directions you have to invert in firmware. But in reality, the easiest way is just to plug them in whichever way you think feels right, which is basically a 50-50 chance. And if the motor or the axis just moves in the wrong direction, just flip the connector or invert it in software. It's as easy as that. You don't need to work that out in meticulous detail. Just like for the z-axis, this is z-axis 2. Just make sure to plug both in the same orientation so that the z-axis actually moves as one, and one side does move up and the other down. Ooh, that tape is making things very tight. So z-axis, these are wired in parallel. I do like my motors wired in series because typically you are dealing with low inductance motors and upping low inductance high current motors. So wiring two high current motors in parallel is going to give you an even higher current one. And wiring them in series is going to give you the same current but higher inductance or higher resistance, which works great for 24 volt systems. For a 12 volt system, either one isn't that great. Stepper drivers typically have a much easier time driving a 3D printer on 24 volts than on 12. So in this case, it's fine that it's wired up that way. It's just the way that the ramps is configured out of the box. Wolfbite is great. Yeah, I actually do have the full assortment of Wolfbites. Did I get that from Hawk 3D Proto? I think I did. The full assortment. I've not tried them out yet, but I will. Maybe this will be a good time to do it. I don't know. I think I'm just going to put some Kapton on here and go with that. Or maybe PI, but I don't want to use a PI sheet for this cheapo bit. So end stops. Again, end stops have the red, black, and green, and that corresponds to the markings here. The one to your right is positive, then negative, and signal. For mechanical end stops, you really don't need. Well, you don't need the positive one. You don't need the. What is this? You don't need the supply voltage because you can enable a pull-up on the signal pin, and when the switch closes or opens, it'll just pull that down to ground. So that's not really needed, but I guess they have a hardware pull-up on the end stop so that you don't have to configure anything specifically for it in software. This is X, same way around, X negative. So let's see, positive and negative, because we get a chance to explain that. This is your 3D printer when you're looking, this is the 3D printer's working space. Down here is 0, 0, 0. This is the 0, 0, 0 corner. And the easiest way to remember which axes are positive is to use the right hand rule. X, Y, and Z. So that like spans a there's a name for this shape. But essentially X positive this way, this way over here, Y positive this way, and Z positive this way. That is always relative from your tool to your workpiece. In this case, the bed is the workpiece, the tool is the hot end. And as the tool moves right, that is Z positive. That is increasing its Z X. That is its X positive direction like that. As the bed moves forward, you might think, yeah, okay, this is clearly moving Y negative, but relative to the tool is actually moving back on the bed, so it is moving in the Y positive direction. And Z-axis, obviously, as the entire assembly moves up, that is your Z positive, your Z height increases. It's a bit confusing to use when you have one machine where your extruder moves up like this, and then another machine like the BCN Sigma where the bed moves down. It's weird. Some firmwares use the up and down for actually moving the hot end down towards the bed, and others use it to move the bed down. It's weird. But yeah, that's the little story on positive, negative directions. So the probe wire colors are extremely weird. I'll admit that. Brown for positive, black. I actually just looked it up because I usually get it wrong and then fry a probe. Blue is Negative, black is output, and brown is positive. Okay. So this is wrong. Yeah, this is wrong. Black needs to go 1 over. Black needs to go where the blue wire is currently. Okay. Good thing we caught that. I don't think it would actually have fried the probe, but it's better to change it now than to find out the hard way later. Why do I not have any pointy tweezers? Oh, let's use these. Let's not use these. Let's use a knife. AKA box cutter. Come on. Come on. And as much as I like to do pond connectors, if you don't crimp them right, you just pull the contact out like that. That is like worst case. Who crimped those? Must have been some guy who has no idea what he's doing. Yeah, this one is coming out as one piece. I'm just going to use a new plastic shroud for these. Cool, let's crimp a new one on. Because we can. Crimping is a nightmare. You will learn to appreciate that nightmare once you tried using something else that is not crimping. Crimping, yes, it's a bit of work as you start out when you first wire everything up, but in the long run, it definitely pays off. Well, maybe if you're only assembling the thing once and then never touching it again, you can go with like soldering stuff together. But in the long run, I found that as soon as you need to change something, the effort you put in the first time to crimp stuff easily pays off. So blue next. Blue is negative. Yeah. Come on. I mean, the crimping tool here isn't great. It sort of works. It's the Chinese SN28B. It kind of works. It crimps well, but it's not really enjoyable to use. That's the other thing. But whatever. Gets the job done. I don't have to use it that often. End stops X space Y space C. Yeah? Correct. DuPont, yes, you can solder those as well, but yep, you do have to crimp them. So there is a space between these connectors. Someone was just pointing that out. We are connecting these. That's actually the reason why I explained that entire positive negative axis thing. We are connecting them. You can just see that the labeling on the side here maybe, yeah, should be visible. Actually, we got some more zoom. Whoa! Yeah. Z negative, that's where the probe is plugged in. Then Y negative, that's where the Y end stop obviously is plugged in. And X negative, because as we move this thing towards the left, clicks into the end stop, that's where the X axis plugs in. So that's wired up. Nice. Next up, thermistors. So we've got the pre-crimped thermistor from the hot end that goes over here into T0 for temperature 0. And then the one from the heated bed into, let's get everything out of the way here, into T1. and we're going to define what sort of temperature sensor that is. I don't know what temperature sensor it is, so I'm just going to guess it's like a generic 100K 3950 beta thermistor generic type, which is probably wrong and it's going to give fairly inaccurate results, but it's all we got. We could swap in a different thermistor, but cost and stuff. So tiny wire, that is, I think, the... Wait a second. Ah, no, okay. So tiny wires, this is the hot end fan. This must be the hot end fan. The thicker, loose ones over here, these are the part cooling fans. So these get in, these get screwed into the controlled outputs, and these thin ones only go to 12 volts to the permanent on input. It's number 13, Malin, wet. XY auto calibration, that is impossible without the Mark 42, correct. Simone, yeah, enjoy your dinner. It's like 10 p.m. for you as well. You should have eaten by now. Come on, don't get stressed out. Right, what else? Power. Yeah. As someone was already pointing out, D8 is for the heated bed, because that's using the bigger poly fuse. There are 2 poly fuses in here behind this white wire. The smaller one is for stepper motors, and the hot end and the larger one is for the heated bed. Actually, let's get these apart so they can cool individually. That's that. So let's actually wire that up right now. Is the extruder a bit tilted? No, the probe is a bit tilted. The probe is not in perfectly straight because it is a bit longer than the original Pinda probe. Now for this guy, polarity does not matter at all. It does not matter because this is literally just a resistor in a metal can. So even though this has like obviously the wires that would indicate a polarity. Yeah, did I open these up? It's not gonna, it makes absolutely no difference which way we screw these in. I don't know, what parts of the world are you guys from? I mean, I've seen various time zones, but what's your time right now? For me, it's almost 11 p.m. By the way, Australia, New Zealand, well, New Zealand actually, is exactly the opposite side of the world for me. So it's literally minus or plus minus 12 hours. Yeah, that doesn't feel right. Let's get them in there. California, Germany, Czech Republic, Switzerland, Sweden, Southern California. And Mega Making wrote something and he's gone. 7 p.m., 10 p.m., 11 p.m. That's not spam, that is valuable viewer interaction. Come on. So it seems like it's a lot from the SNL. A lot of people who should be in bed right now from Europe. I'm guessing your bosses are tolerant. You do have an excuse. When you show up at like 10 p.m. for work tomorrow. $2 a.m. in Russia. Come on, go to bed. Get some sleep. Okay, I did miss most of those chat messages. But yeah. Now, these are sort of important to get right, polarity-wise. Let's double check these. So the leftmost ones are positive and the rightmost ones are negative. So that's this way. I usually like to mark these just on the board, just to have like that double security, just to have a very visible red mark on the connector, and positive, positive, and this is negative. Just to have like the most visible indication on these. It's not pretty, yeah, but it's, if it keeps your board from burning out, it's definitely worth it. Ah, yes, Mark Swift, good idea. What is the weather like? I've heard some snowstorms we're going through the US right now. At times of the year where you're not supposed to have snowstorms, I guess. For me here in Bavaria, it's rainy, windy, nasty. It's not like spring is supposed to be. Is it possible to scale up the design? Yeah, I've talked about that. Up to a certain extent, I guess adding 50% size isn't going to hurt that much. Well, UK, so it's raining. Actually, I've been to London a few years ago, and we've had beautiful weather. We've had like the most perfect. We've had the most perfect sunny, not too hot, not too cold, slightly, a slight bit of wind, but perfect weather. So that's what I remember about London. So whenever you guys say, yeah, it's raining all the time, I don't really believe you. No ferrule on the end of a cable pains your electrician's heart. Well, these have the ferrules on them. This one doesn't, because these are clamps specifically made for unferruled cables. Plus the ferrules would probably be too large to even fit in there. They're already slightly too large to fit in these. Got it. Oh, I did have to add, wait, I did have to add the hot end cooling fan to one of those. Okay, let's do that in a second. Let's move on with the rest of these parts. So hot end heater, can someone look up what the hot end heater is? What the pin is, whether it's the D10 or D9. I think it's D10. If I'm not mistaken, these are not tins. That is great. D10 and D9. Those are our options. One of them is going to be the part cooling fan. The other is going to be the hot end heater. It's kind of a shame to waste a high power output like that on the. D8 10 for hot end. Wow. D10 extruder 1. Well, it's extruder 0, so okay. The populace has spoken, so it is D10. Wait, wasn't that like Eminem's band or something? What are they called? Also, someone asked, hey, if you know that these MOSFETs are crappy and that the connectors are crappy and that sort of stuff, why aren't you adding an external MOSFET? That is a good question. which I will answer with the universal argument of cost. And granted, you can get like an external MOSFET board for maybe $2 to $3 or something. But cost, and I do honestly want to see how much this RAMs can do, and if it catches on fire, that's even better. Hey, that's gonna be spectacular. D12, okay. How about doing a retro build? I can think of a lot of fun, a lot of ways that are more fun than building something like a Darwin or a Salesman or something. I don't really know if I want to do that. I do want to do a flashback episode on what Skyforge felt like back then. Hey Simone, you're supposed to be eating. Yeah, cooling fan up next. That is the one that we extended, so we do have these slightly thicker wires on it. And this is like the only one where polarity actually matters. No, not all polarities matter, but the one for the cooling fan does, because this guy is not a resistor. This guy is a bit more complex than that. And the way these work is the way these work is that the positive pin is always connected to the input positive. So if you put a digital multimeter on these, you're always going to measure positive 12 volt on the pin, and when it's off, you're also going to measure positive 12 volts on the second pin. The only thing that happens when they switch is that the MOSFET actually pulls the negative, or what is marked as a negative pin here, it actually pulls it down to ground. And it's called low side switching, and it allows you to use the cheaper N-channel MOSFETs. But of course, if you have something that connects between your loads, if there's any sort of communication interface, you can't really use that. Okay, 1, 2, 3. I'm having a horrible idea that is probably going to get some people on the spam list, but how high is chat going to be able to count? I wonder. If there is something you need to bury in chat, just ask them to count up. What is my opinion on building a 3D printer from scratch with V-slot rails and wheels instead of smooth axes and linear bearings? The TiVo Black Widow and the Mendel Max were the two machines that used linear rails like that. You guys are failing hard. 3? Yeah, those were two printers that used linear rails, but I wasn't really happy with how they used them. It felt like they were overbuilding, but were still being flimsy printers at their core, just trying to cover something up. So yeah, that might be a chance to do something a bit better, a bit nicer. You guys missed pi. Just by the way, why would you skip over that? Yeah, and V-slot, obviously, they need a bit of adjustment. My ideal 3D printer would probably be using just linear rails, just He-Win rails or something along those lines. And yeah, maybe aluminum profiles or a few custom CNC parts. But I think that is it. I think we've got everything wired up. Can you believe it? Let's double check. So we've got 3 end stops. We've got X, Y, and the bed sensor. Zoom you guys back in. That's the dry box back there, which is actually working out fabulously. So 3 end stops, X, Y, Z. We've got 2 thermistors. We've got the hot end and the bed. We've got 2 Z-axis motors. We've got a Y-axis motor. We've got an X-axis motor. Obviously over here on the aux pins, that's where you would connect an LCD screen, SD card reader, something like that. We've got the heater, we've got the heated bed and a part cooling fan. We've got a power input and we've got the hot end cooling fan directly wired to the 12 volt input. Perfect. We don't have any stepper drivers in here. That is correct. Yeah, but stepper drivers are optional. What I do want to do is just plug the thing in right now. Because not having stepper drivers in here isn't going to hurt. It's not going to like blow anything up. But if this thing just blows to bits right now, then why even bother moving on? I thought I had another extension cord. This could be difficult. Problem is I'm using like 15 to 20 outlets right now. And honestly, I don't have it. What did I do with those? I just bought a few extras. Oh, I guess I can unplug these guys. That's the Sigma and the Prusa and the Element. Yeah. It's not the longest extension cord ever, but that's good. So, let's see, and we can turn this guy into the camera. There we go. You guys ready? Power supply is over here. I'm hoping everything is wired up. If the stream goes black in a second, you'll know what happened. We're gonna have blown a fuse, obviously. Let's see. 3, 2, 1. Fan spinning up. No smoke. Yeah. Well, actually, that's the hot end. The power supply fan is self-regulated, but the hot end fan is spinning up right here. And the end stop is triggered. Look at that. The end stop is even working. So right over here, you can see the end stop glowing as we click it. And that's the hot end fan. There's something heating up. That's the other question you should look for. This guy is not heating, this guy is not heating, and this guy is also not turning. So the outputs are okay. And stop right here. This one glows as well when I click it. And lastly, the bed probe, just to double check that that also works. There is a very faint red glow that you might not be able to see. But right up top, it has a clear nope. That's the 400 volt output over there. There, 400 volts, 3-phase power. That's our Starkstrom in Germany. So if I ever need to build a big printer, you probably can't see it, but it just faintly glows up there in red. Okay, no smoke. That is good. Let's unplug it again and. The heated bed is D8. Yeah, thanks for that tip. That was like an hour ago. Will it be ready to print? Well, we need a bit of firmware first. That's going to be a bit tricky also. Okay. So let's plug in some stepper drivers. So I've got a few here that already have like little heat sinks glued onto them. Ideally, if you look at how these stepper driver ICs work, you would have the heatsink on the bottom. But I mean, again, rep 3D printing. It's not about engineering things properly. It's making stuff work, and the heatsink on top sort of also works, but it would be better to have it on the bottom. Let's see. So I have one without the heatsink. I think I'm just going to put that one in the... there's not really an axis that's going to use less power. The Z-axis is going to drive two motors. The E-axis is already at its limit. So maybe just put another heatsink on this guy. Nah, whatever. Let's try that for the Z-axis. The Z-axis shouldn't be that power hungry. And a quick tip on figuring out how to orient these. Nope. Yes. You should be able to see these two. Let's actually use a zip tie as a pointing device. You can see these two sensing resistors over here. These are, first of all, these are the output side, and you are also going to be able to see like thicker traces on one side. We just, yeah. Well, you can see them. They are also labeled as like 2A, 2B, 1A, 2A, but that's often hard to see, and I usually just look for the thicker traces, and those go towards the motor output. As easy as that. So there is the socket for the Z-axis, there's the Z-axis connectors, and these just go in like that. It might be different for other boards, but for these, that's how it works. Might be different for other control boards. That's what I'm trying to say there. Okay, that one doesn't go in all the way. That's great. Yeah, the thing is the... nothing a bit of force can fix. The thing is the... What was I going to say? Yeah, reference voltage for like current of these drivers. It's different from driver to driver. So sometimes you're going to see tips like, yeah, just set your drivers to 1 point something volt reference. Crap, this is stuck. Yep. Ramsport didn't come with stepper drivers. No, not for $3. Yeah, you're sometimes going to see tips like, yeah, just set your reference voltage to 1.2 volts or something. It's not universal between drivers. Some drivers use different potentiometers, have like an external voltage divider or something. Others use different sensing resistors. That is like one of the main differences between the Pololo and the original Pololo drivers and the step sticks. The step sticks can only deliver half the amperage of the genuine Pololo drivers. So when you set both of them to the same voltage, the Pololo ones are actually going to deliver twice the current as the step sticks. So that's not something that is like universal between even Allegro drivers. These are all Allegro A4988s or 4983 maybe, I don't know. Might be a few old chips in here. And especially when you mix like TI chips with Lego chips and then throw a few Trinamics in there, it's very different between drivers. There's no universal relationship between the voltage you set on the potentiometer to the current you actually get on your output. Just something to keep in mind. Okay, extruder one. Yeah. I wouldn't worry too much about setting these too high current-wise. They all have thermal protection, so if you go over current with one of these, it's just going to shut down. It's just going to, it's just going to shut down. It's not going to burn anything up. But when it does shut down, you are going to lose steps. There's just no way around it. So like someone commented somewhere, hey, I've got this issue. My 3D printer just keeps turning off an axis. It's like a rhythmic pattern where it's like that is that exact thermal shutdown where it heats up, then it shuts down, and it cools down, and within like half a second it cycles and resets. So is this a DIY build? What? Okay, let's try again with these stepper drivers in place. Let's see, so if I show you that side, if anything explodes, it's going to go this way. These are disabled. I don't know what this this Arduino is running. Actually, I don't know what sort of software is on it, so it might do crazy stuff, but it is looking good. There is nothing blowing up. There's nothing overheating. Stepper drivers were disabled, obviously, so... Oh, my camera's gone. Yeah, okay, so apparently... Sweet. This one's still working. I don't know if that's a correlation or something, but let's switch back to that guy and see if we can fix that. Deactivate, activate, yeah. Yes, the good old Chinese boards. Right, Technicolor. Let's actually get some firmware up on this guy. We are going to need a USB cable, which we have at hand, thankfully. Right when I press the power button. Yeah, like, electrical interference is a real thing. There are reasons why you get, like, CE and FCC labels on your stuff. For that exact, that's like literally what the FCC conformity statement says. This device may not produce interference to a level where it might, whatever. But yeah. But this guy's back up. Cool. Exactly when I press the switch. Well, okay, to be honest, I am also running like USB extension cords and stuff, so it's no surprise that something's not going perfectly. Now, if I grab one of these USB cords, actually let's grab a long one. And I will need some USB hub to plug it into. I have no idea if this is actually gonna break a camera again. Let's see where we even have a spare USB down here. Okay. Let's plug that in and see if anything breaks. Other way around. I can't wait for the day where USB Type-C just takes over everything. 3, 2, 1. Again? Okay. Apparently that USB hub just isn't happy with what's going on right now. So now I've got the printer plugged into the PC. Deactivate, activate. It's got to reset the capture card. Weirdness. Yeah. Chinese Arduino in a Chinese USB hub into a Chinese laptop. What could go wrong? Power supply is unplugged right now, by the way. What was that? That was another glitch. Okay. Something is really wrong. Is at least the audio is working, so that's like my big grief. Camera is still lagging every second or two. Ooh, look at that. Look at that fluorescent flicker. But now, okay, it is 11:30. Let's try and get some firmware up and running. Yeah, I do want to see it move. I do want to see it move. Okay, so I am going to use, I'm hiding behind chat. I am going to use the official Marlin firmware. I'm not going to use Prusa's branch because I don't know how much they actually change when it comes to like using it with regular hardware. I know they have a different library for the LCD in there, so yeah. So I am going to use the standard Marlin. It also has mesh bed leveling, well, it has bilinear bed leveling. Mesh bed leveling is like the manual version, which we don't want to use, but it has automatic mesh bed leveling in there. So this is going to be a, even if you bent this bed, which it's probably already bent, even if you bent that, it's going to go perfectly flat on this thing. So let's see. Okay, firmware is downloaded. That's the wrong Explorer window. Now, where did I put this? By the way, if you've never used BitTorrent Sync, I can highly recommend it. I use that to keep my stuff synced between the laptop and the workstation, and it's just awesome to use. And I also use it to sync my Arduino libraries. So, oh, I've got that on the other disk. Okay, so I've got one Arduino set of libraries set up on the desktop and on the laptop, and they're synced together. So when I open up an Arduino project that I created on the workstation, I can just open it up down here on the laptop and use it, and don't have to worry about setting up libraries and keeping them in sync, because that's all automated. Yeah, people are saying it's not really secure, but then again, it's probably better than Google Drive or Dropbox or anything like that. Marlin. Okay. So Marlin. There you go. Prusa Marlin. That's the Prusa branch of Marlin, and standard Marlin. That is the one from literally from GitHub that I downloaded yesterday at 7:49 p.m. Sync thing, yeah, I've tried it, but it's not stable for me. It just crashed constantly and like got stuck in loops and whatnot. I actually use BitTorrent Sync to back up my my video hard drives, which is like 5 gigabytes of data, terabytes of data nowadays. And I just sync that to another PC that also runs a RAID array, well, storage spaces array. And yeah, it works pretty well for that. It works very well for keeping multiple terabytes of data in sync, whereas SyncThing would just end up like re-indexing everything and just never got to syncing. Okay, Marlin is open. I'm hoping that is big enough for everyone to see. Is Repetier the same as Marlin? No, it is not. It is a completely different firmware. Do I have an LCD? Not yet. I'm going to do it through print run, which gives me a console, so we do get very direct control over everything. Let's actually scale this up a tiny bit. Let's knock it up to 15 so you guys can see a bit more. Change font. Yeah, okay, done that. Yep. Is there a pre-configured SmoothieWare for Prusa? I don't know. I might make one. Updates are available. Don't need that. Delta printer. Okay, so let's start from the top. We are in configuration.h, which is the main configuration file for Marlin. You can set like an internal version counter, whatever. You can get example configurations for Delta. So if you're configuring a Delta, you can just grab that standard or that default configuration for the Delta and don't have to mess with this one. Right, author, Tom. And this is just a message that's going to show when the machine boots up for the first time, so we know, okay, this is the firmware that I configured on March 19th, and it was me that configured that. Build an unraid NAS. Yeah, thing is, power here in Germany is sort of expensive, so I don't want like a full 5 hard drive quad core NAS constantly powered up. I just use the PCs that I have anyways. So, define motherboard, RAMs 1.4, extruder, fan, bed. That is the order of outputs that we used. Let's double check that. Extruder, fan, bed. That is correct. You can also use like extruder bed or other configs, but that is like the most common one. And most boards are actually compatible with that pinout. For most boards like Rambo, Roomba, anything else that, or yeah, Rambo Mini even, anything else that has the at Mega on it has a pretty high chance to have the same pinout as the ramps. Just because it's stuck. UID, we're not going to define that right now. It really doesn't matter. One extruder, correct. Multi-extruder that shares a single nozzle, that would be something that... Oh, would it be? Yeah. Something like the Prusa multi-extruder or the Cyclops. Switching extruder, no, we don't have that. Mixing extruder, also negative. Offset of the extruder, since we only have a single hot end, doesn't matter. Power supply, we could use the switch for an ATX type power supply, but we don't have an ATX type power supply, so that's okay. People are still talking about NAS. Should I increase font size even more? Yeah, I was considering like getting what are the nicer NAS boxes where you can just plop in 4 hard drives and then it pops them into like a RAID array and you can remove and add some however you like it. But those are also pretty expensive, like $250 just for the box. And I can buy a few terabytes of hard drives for that. So temperature sensors, sort of important. 100K, that is like the generic setting. Someone mentioned they are number 13s, I think. And hot and all in one. We don't really know which thermistor we got. I think, please do, okay. It might get a bit crowded. It's up to 18. Ooh, okay. Now I can see it from here as well. 100K, we don't really know which thermistor we got, so I'm just going to stick with number 1. I know it's going to be slightly inaccurate, so... Yeah. 13, 11, 39, 50. The thing is, even the thermistors that are in the data sheets aren't really accurate most of the time. So I guess it's anyone's guess whether it's a 1, a 10, a 13, an 11. Oh, 10 could also work. 13. Right. Whatever. It doesn't really matter. You're going to have to tune in temperatures anyways when you're using a thermistor with an unknown beta value or unknown parameters. Also, like the resistors on the ramps, they are 1%, but 1% is a lot in thermistor pull-ups values. The tolerances on the ramps board can throw off temperature readings as well. Dummy thermistor, we don't want to use that. Redundant sensors also don't have that. Let's just heat up wait times. We're good with that for the bed as well. Min temp 5 is okay. And when the Arduino or the board senses that the temperature is lower than that, it's going to shut down. Max temp. So heater 0 max temp. We're going to set that to 250. 250. I'm going to leave that at 250 because we have Teflon or PTFE all over that thing. We have it at the thermistor clamp and we also have it inside the heat break. So 250 is the max I want to go. And for this tiny heat bit, I don't think we should go, or for this flimsy heat bit, I don't think we should go more than 120. Okay, PID settings. This is going to be something that we will be auto-tuning. Temp sensor bed should be set. Yeah, we set that, guys. We set that. Where is it? Temp sensor. Oh, crap. Okay, I set the wrong one. There we go. Actually, we can, whatever. It really does not matter which one we use. Okay, min temp, max temp set. These are just safety features. PID settings, we are going to auto tune that later on, but for now we're just going to use the default values. I guess you could use the values for an E3DB6. Sort of. Set bed temp. What? What are you talking about? You got wrong the bed temp type setting. What are you talking about? Teflon tube can go to 265, yeah, but it's not going to last long for that. Set bed temp. Okay, I guess we already fixed that. Let's move on. PID bed temp, yes, will do. And we are going to enable that. Limit switching. Yeah. We are, well, 255 if we really have temperature issues with the MOSFETs on the board. We can always limit power there. It's not going to like linearly just reduce current. It's just going to it's going to chop it into shorter intervals and reduce the on times for the pulse width modulation that it uses for the bed, for the PID. So in case we get temperature issues, we can always turn this down. And also these values, these will need to get auto-tuned. Right, extrude min temp, well, we can pull out PLA at 110, so that's okay. Increase font size, pff, nope. Extrude max things, yeah, that's just the regular safety features, that's okay. Thermal protection, hot end and bed, yes, keep these on, definitely. Right, now here's the interesting part. Don't get any silly ideas, guys. Right, so we are using end stops. We are using min and min end stops for X, Y, and Z. We are not using the max end stops. So that is taken care of. I've got to switch on PID heating for extruder. What? It is enabled. End stop pull-ups, I don't think we need these because the end stop boards have pull-ups built in. So that's going to stay commented out, so these are disabled. If disabled end stop pull-ups, yeah. And counter ground false here, yeah, so you can invert these. We are just going to check that in firmware in a second, whether or not we need to invert the individual end stops. That's okay. Motion, yes. Steps per unit. So this is where it gets interesting. 80 is the default for 20-tooth GT belts. So there's the live Prusa calculator. Hey, who made a video about that? Cool. So obviously configuring the clone Prusa with the original Prusa calculator. So we are doing 2mm pitch, 16-tooth pulley. So we're getting 100 steps per millimeter. If we were using the 20-tooth pulley, we'd get the 80 value that's default. But of course, with the 16-tooth pulley, we are getting more torque and more precision. So X is 100. And whoops, Y is also 100. Now the Z-axis we will need to configure as well. Why so many tabs? This is nothing. My workstation has even more tabs open. 5 metric. We've got a 1.8 degree motor. That is great. That's not white. That's gray. Crap. 1/16 microstep. M5 is 0.8. That is correct, which is 4000. So the default is actually correct in this case. 4000 and extruder 500 is about right, I think. Maybe. Well, nah, it's probably a lot lower. Let's just try this. I think this is about right for an MK8 gear. We will have what? I have 16 tooth. Put around 120. Oh, 120 sounds right too. Pull-ups are still enabled? No, they are not. Max feed rate 300. Maybe take it easy for now. Let's stick with 200. 200. Z-axis 5 is usually pretty fast for a Z-axis, especially like the tiny M5 pitch. Yes, micro-stepping jumpers are set in 25 millimeters a second. That's okay. Acceleration 3000, that's okay. We can always lower that if we run into issues. X jerk, Y jerk. I also like to lower this just slightly. Just because having values like these, you know, X and Y jerk, if you have a stiff motion system, it's going to get you skipped steps pretty easily and a lot of ringing. Well, yes, they are. Define, oh yeah. For once, chat is right. Okay, thank you for that. Jerk, slightly lowered. Someone's also suggesting lowering acceleration a lot. I'm just going to leave it at that. Some other machines I've run with... no, Z steps are correct. I've actually run other machines with like 9,000 accelerations, etc. So... yeah, 400 is perfect. So this is what I'm trying to say. For once, chat is right. Now people are saying, yeah, the Z-axis steps per millimeter is wrong. 4,000. That is exactly what the calculator is spitting out. M5 1.8 degrees 16th, and we get 4,000. So exactly. Yeah, obviously lowering accelerations is going to get a bit better print quality, but like, well, let's just leave it and let's see how it does. Okay, Z probe options. This is like the interesting part. I think I already uncommented this guy. Just by default, this might be commented out. So, probe offsets from extruder. Joe Anon, you probably didn't pay attention. X probe offset from extruder 10. So let's just quickly measure that. I think we could just look it up in the CAD file, but why look it up when you can just quickly measure it? It is slightly offset from the nozzle too, so this is offset 20, bit more like 21 millimeters in the X direction, so that is positive. That is a positive offset. And right here, this doesn't need to be like super exact. This just needs to be in the right ballpark. 2 millimeters plus minus is perfectly fine. So X direction was 21. And Y direction is, yeah, correct direction, 10 millimeters, so that's right. C probe offsets, that's something we will need to calibrate. Just compile and print and wreck your printer. Nope! Probe speed. Got it. Sounds right. Unkey probe. This looks weird with the big font. That's okay. That's okay. Inverting stepper enable pins. Did we skip something? No. We're not disabling X, Y, or Z. I guess we could disable the Z axis, but doesn't matter. Extruder, don't want to do that. Invert these directions. Let's just all set these to false for now. And we can just simply flip the switch if we need to. X home direction, -1, so that one goes into the left side, Y home direction, that one goes towards the front, and Z that goes down. That is okay. Min software end stops. For now, I'm going to remove these because when we try things out, I don't want to be running into these end stops all the time. So now here's where it gets slightly juicy. So X, Y, Z, not so much, Z doesn't matter, but X and Y positions. These are the positions when we go to the absolute home position. And switch over here. That off as the extruder is moving into the end stop. So right now it's triggered and you guys can see that there. So as that moves into the end stop over here, click, click, click. This guy is still a bit away from the corner. Obviously we would need to move this entire thing down. But the offset where your actual usable print area starts is about 10 millimeters from this edge. So when it homes, the printer shouldn't think it's at 0, it should think it's at negative 10. So when the slicer tells it to go to 0, which is the slicer's minimum print area, the extruder is actually going to move a bit over. That is something we're just going to have to try out and calibrate in as we tune the printer in. But the other thing we have to keep in mind is that this is more than 200. This is definitely more than 200 millimeters. What's running into this? So there's the zip tie on the back that we don't want crashing into stuff, and let's just eyeball this. It was like 23 centimeters, so 230 millimeters, so that we can actually move the entire range of the x-axis. Solidus is asking, should Y be +1 at the front? What +1? +1? Anyways, filament runout sensor, that's something cool. We're not going to use that. Mesh bed leveling, we're also not going to use that because mesh bed leveling is the manual implementation. As you know, last time I checked, mesh bed leveling has you moving the hot end down onto the bed and just manually trying where the hot end touches down and then entering that essentially. And auto bed leveling is the same thing, but with a sensor. So that's what we're going to use. And we are going to use bilinear. There are a few different options. So 3-point is what, like, I think, I don't know if the newer printabots use that still, but it essentially just probes 3 points on the bed. So 1, 2, 3, and then it fits a plane. It just fits a plane into that entire surface. So it assumes that +1? No, this is Z negative. It just fits a plane in here and assumes that your bed is flat. Linear does basically the same thing, but well, I guess we can use it with this perspective. But instead of just probing 3 points, it probes 4, 9, so 3 times 3, or 16, so 4 by 4 or more points, and then fits a plane with minimum error into the points it probes. Again, assuming that the bed is flat, but measuring more points and giving you a better fitment, essentially. That's also not what we want because this bed is not going to be flat. That's not what it does, or what's useful here. So bilinear probes several points in a grid. The result is a mesh best for large or uneven beds. That is exactly what we need. So we are going to go with auto bed leveling bilinear. I already uncommented that before. Detailed logging, not going to use that for now. So if enabled, auto bed leveling bilinear. Set grid points X, 3, and we're going to go with 4. And it's going to use the same value for the y-axis. So we're going to get 16 points in total, which should be a pretty good fitment for the entire thing. Yeah, X should be -10, but we're not going to worry about that for now. Left probe bed position. Actually, let's inset these ever so slightly. 40, 40. Well, left, obviously, we do have a bit of a gap there. So let's go with 50. 50, yeah. 20. Right, so that's 230 negative 50, so 180. Front 20, back 180 as well. So that's just going to be insetting the probe points into the bed so that it doesn't probe the exact corners, potentially running into these screws on the edges, and also doesn't run off the edge and just crashes into the bottom. So just a little hack there. Minimum probe edge, minimum outer margin, yeah, to validate, that's okay. Okay, we're going to remove that for now. This would fit not just tiny triangles into each square of those probe points, but it would actually interpolate those between the probes, or probe points. Homing bed center at 0. Homing speed, yada 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 yada. Sounds good. EEPROM, not gonna enable that for now. I don't know what this Arduino has stored in its EEPROM. Inch mode, why would you ever want to enable that? Preheat, that's for the LCD. Nozzle parking, wiping, that's useful for the load spots. I guess, well, and the LCD. Obviously, this one doesn't have an LCD yet, but you could add one. That's done. Servos, yeah, you can do a whole bunch of stuff. Advanced has a few safety features in there. By default, they are enabled, which I really like about them all in firmware nowadays. They weren't always enabled, but that should be all we need for now. Let's see if we can compile this guy. So one of the good practices to do while configuring this sort of stuff is just compiling your firmware regularly. If I move myself over here, I mean, you can see the progress bar in the compiling sketch. Actually, I could move it up here. Yeah. One good practice is to compile regularly. It does take a while. It is gonna, run your CPU for a while, especially for the first time. But grabbing the firmware, compiling it once, just first of all checks that everything is in place, that all the libraries are working, and just compiling it every few changes you make. Because if you mess up a single semicolon, or miss a bracket or something like that, you're not going to find it. It's pretty hard to find it, because the errors that Arduino throws are pretty much worthless. So just enable that wherever you can, or compile it wherever you can, and you should have a bit of a better experience there. Why is this still coming out? I don't know. Okay. Tools, board. That is the correct Mega that we're using. Arduino Genuine Mega. And serial port COM8. Upload. Let's see if this thing actually uploads. I don't see any LEDs in here. Ah, there it is. Ooh, it gave me 2 blinks and that was it. There's an LED over here. Usually that flickers wildly right now. Come on. Still saying uploading. Probe offset is set? Not yet, because I don't know it yet. Okay, the upload is stuck right now. If I unplug this, does it actually cancel? Yes, it does. Okay, so it is the correct port, but it's not uploading. Power the printer? maybe. Let's try that. Yeah, that might be a good idea. Maybe it's gonna fry the camera again. No, it does not. But let's try it again. Is the stream down? No, it's not. Port is not connected. What? Tools, ports, COM8. Should enable verbose. Yeah. During upload. Timeout, error, no info. Can't set COM state for COM8. What? Selected wrong port. There is only one port. I'm hoping that's the one. And yeah, it did cancel when I unplugged it. Let's just close this guy. Save it, close it, open it up again. You never know. Reconnect without hub? Yes, I'd like to, but I don't have any more USB ports, unfortunately. Set the baud rate? No, that baud rate doesn't matter for uploading. Do I have an ISP? Yes. But I don't want to use it right now. I know the serial port works on this guy. Can I open it up right now? I don't think I can. I know this Arduino works. I know I can upload on this laptop. Choose Arduino Mega 80K. That is actually a good idea. Board Arduino Mega 80K, because there are the same thing, but apparently they upload differently. That's one of the, well, let's see, get board info. Does that actually help? Arduino Genuine Mega or Cylinder upload. Rebuilding all. Okay, so now obviously the OBS is eating quite a bit of CPU here. And this thing has been pegged on 100% for quite a while, but well. Compiling sketch. Yes, this is a cheap Arduino clone. I've been using, actually I've been using that exact one for quite a while without any issues. That has been powering the Middle 90 for a while. Okay, what is this extension cord? Let me see. So I do have a few extension cords right here. This is the front camera. So if I unplug this, we're gonna lose the close-up camera. But it's worth a shot. So let's do it. And plug this guy directly into the laptop right here. So let's see, tools. That's not good. USB device not recognized. Let's actually power it off and plug it in again. Blink, blink. Yeah, that's the thing with the power concept on these boards. It's not great, and it's a good chance that not removing that diode that supplies 5 volts from 12 volts to the Arduino might be the culprit here. Oh, I'm being covered up by a chat. That's cool. Where can I move this? There, maybe. COM port is correct. That is the right one. I've already checked that. Cut the power. Yeah, did that. That's looking better. Timeout. Ah, let's pull the ramps and see if it works better without it. Yeah, that's just a static image right now, unfortunately. Bluetooth serial, yeah. Okay, so that's unplugged. Let's try uploading again. Test by using different megas. Shorter USB cable. This is the shortest one I can use basically. Ah, here we go. Now it's uploading. Okay, so with the ramps on top, it doesn't flash. That is interesting. And that's going to be pretty painful. But why though? Why is that? Is there something? There must be something on the ramps that shorts out some of the. Well, let's see if we can get a serial connection. So serial monitor, yeah, this one does do parallel sending serial port parameters. Oh crap! Come on. Are you trying to tell me that this ramps actually bricks the Arduino? That's with the ramps on. That's with the ramps on and powered. Access is denied. Okay, let's try that again. Nope, that's the wrong tool. Why, oh why? Had to unplug the end stops to get it working for some reason. That could be an explanation. Yeah, if the end stops have hardware pull-ups, that could explain it. Let's try that. So end stops are unplugged. Let's close this guy and unplug the entire ramps again. USB device not recognized. Okay. So apparently it does not. Oh, as soon as it's powered up, it's showing me that the USB device is malfunctioning. Let's see, okay, so now apparently it's working. By the way, don't misspell. Ah, here we go. Prontoface. Okay. So we are connected to the printer, but the problem is as soon as I turn it on, I suppose it's just gonna brick up. M114. Why doesn't this do anything? Why are we not getting any responses to that? And we're also not getting a temperature reading. That is not good. And I guess as soon as I turn it on, it's just not going to do anything. Nope, can't write to printer, disconnected. Okay, well, that's going to have to be it for today because there is nothing I can do right now, to be honest. I have chit chat disabled, yes, but like stuff that doesn't work. So that's gonna have to be something that I'll need to investigate a bit further. Also, it is... Now it's blinking. Okay. Also, it is 5 past midnight, so it's bedtime for me for today. And I don't really feel like messing with this entire thing. But yeah, build is complete now. The only thing left to do is to figure out how to actually get it printing and how to get this thing working at all. Well, it's not even close to printing with the board not working. If anything, I can just throw on a different board because I have a few different options. 1, 2, well, many. I also have a different RAMs if we need to try that, but that one is just not... there's not a whole lot of RAMs left. I guess it would still work. I guess we could still use the temperature sensors and stepper drivers. I guess it would still be functional, so that's always an option. But yeah, for now there's not much more that I can try and do. So thanks everyone for being here. Thanks for watching. Hit the like button if you enjoyed. If you enjoyed this bit of frustration. Thanks for all the tips today. Thanks for just being here and hanging out. Get subscribed, like the video, check out Patreon if you want to do more crazy one-on-one hangout stuff. And yeah, see you soon. Bye bye. Have a nice evening, morning, day, or whatever.